Hey guys, welcome back to Math Principles. Last couple of times we've been looking at linear functions. So we looked at graphing linear functions, we looked at applying linear functions, writing them. Now we're going to look at linear systems. Now a system of linear equations um, are equations, two or more, where we use the same variables and the graph of each equation is a line. Now this is specifically for systems of linear equations. The graphs don't have to be lines, but that's what we're going to work with here. Oftentimes we use a brace to indicate that the two equations or more equations in the system belong together. So this symbol right here, this goofy looking guy, we call that a brace, and that holds those equations together and tells us that they exist within the same system. Now, if we're told to solve a system of equations, what's really important is we want a number, or an ordered pair, more accurately, that is a solution to both of these equations. So if I look at y equals x plus 3, that's this green equation right here, this green graph, okay? I could say that the point 2, 5 is a solution to that equation, okay, because it's a point on this line. If I look at the equation y equals negative 2x plus 3, that's this red line, okay, I could say that the point 2, negative 1, that ordered pair is a point on that line, therefore it is a solution to that line. But if I want to solve a system of equations, I need a point that's on both lines. So what I'm looking for is the point where those two lines intersect. So in this case, the point where these two lines intersect is right here. Whoop, right here. Okay, and that is the ordered pair 0, 3. So since they intersect at the point 0, 3, that's the solution to this system. So if we want to solve a system of linear equations by graphing, what we're going to have to do first is make sure that we have y by itself in each equation. The reason we do that is it makes the next step, graphing each equation, very easy. Once we have y all by itself, we graph each function and we find the point of intersection. The point where those two lines intersect, that's going to be the solution to that function. Okay, so right here, where these two lines intersect at 0, 3, that's the solution to this system. Now, there are a couple of instances, a couple of special cases here. And if you think about it for a second, I bet you could come up with exactly what those special cases are. Well, one special case is that the lines don't intersect. If they're parallel lines, they don't intersect. There's no point that's on both lines. If there's no point that's on both lines, there's no solution to that system. The other possibility is that we get the y by itself and we end up with the same equation for both lines. Well, if we graph those, we're going to have the exact same line twice. So there's no unique solution to that system of equations, and that's what we would say, no unique solution. Not that there's no solution, because any point on that line is going to be a solution to the system. We need to say that there is no unique solution. So there's a lot of solutions to that system of equations. So I want to solve each one of these systems by graphing. Okay, so the first thing that I need to do is get y by itself. Let's take a look right here, example 1, they're both by themselves. Then I need to graph each function carefully. Now guys, I don't want us to have to draw an XY plane and hope that our graph paper is good enough, or hope that if we have graph paper, if we don't have graph paper, that we sketch a close enough grid. So we're going to use instead a couple of graphing calculators. Now the first one I'm going to show you is online. So you'll go on your browser, and you'll go to desmos.com. Okay, hit enter, and right here, dead center, is graphing calculator. We click on that, it gives us an opportunity to graph whatever it is that we need to graph. So let's go take a look at those functions. We have y equals x minus 2 is the first equation that I need to graph. So I'll come right here where that cursor is blinking, and I'll type y equals x minus 2. Okay, and you notice as I'm typing that, this graph appeared on the grid. Okay, and I can see this red line, and this is y equals x minus 2. And they've even put a couple of points on the grid for me. Okay, I've got my y-intercept, and I've got my x-intercept. But those aren't the points that I'm most interested in right now. What I also want, or what I really want, is the point where that intersects the other function. So I press enter, or I could just click right here, and that'll give me another spot to type another function. And I want negative 2x plus 7. So I'll type y equals negative 2x plus 7. Okay, now double check, make sure these are both the graphs that we want. So y equals x minus 2, yep. Y equals negative 2x plus 7, yep. Okay, so we've got our graphs. Now we want our solution. Our solution is the point where those two lines intersect. and they intersect right here at the point 3, 1. Now, I want to show my graph. So Desmos does this thing for us where I can actually just copy this picture. So I want to zoom in just a little bit, okay, and I'll click and drag so that I have this near the center. Okay, my solution's right here near the center. Now this little guy right here that allows us to share the image, okay, we're going to share this graph, and we'll export image. Okay, and it brings up this for us. Now, we can download this image and we can go through all that business, or if you're on a computer or if you're on your phone, you can probably press and hold on this. If you're on a computer, you can right click on that image and you can copy that image, okay, and then come back here and we can paste. Now, it makes the image way bigger than we need it to be, so you'll probably need to shrink it down. No big deal. Okay, but here is this graph of our system of equations. And there we go. There's our graph. There's our work. Now what we want is the solution to this system of equations. Well, the solution is going to be the ordered pair 3, 1. And that's the solution to our system of equations here. Okay? Now, on example number 2, I have to do something before I can really get to graphing this, and that is I need to get y all by itself in each of these equations. Okay? Now, to get y by itself, we're just going to use some regular old algebra. Okay? For instance, on the second one, I have x plus y equals 2. So all I need to do is subtract x from both sides, and that'll give us the equation where y equals negative x, or the opposite of x, I should say, plus 2. Okay, and there we've got y all by itself. Now, for this equation, we might have to do just a little bit more. Okay, now the first thing that I'm going to do is still move that x to the other side. So I'll subtract 2x from each side of the equation, and that will give me the equation 4y equals negative 2x plus 12. Now, I want y all the way by itself, so I'm going to then divide both sides by 4. Okay, and on the left side, that's easy because the 4's cancel, and all I have now is y equals, now negative 2 divided by 4 is negative 1/2. Okay, still times x, plus 12 divided by 4 is 3. So now these are the two equations that we want to graph. Okay, so we'll come back here to Desmos. Okay, close this guy, we don't need that anymore. Okay, and we'll clear out our old equations. Now, one of those equations, the first one that we want now, is y equals the opposite of x plus 2. So negative, then x, then plus 2. Okay, and there we go. I'm going to move this closer to the center there. Okay, so there's our first equation. Then our second function, we have y equals negative 1/2 x plus 3. Well, here's something kind of cool on Desmos. How to type a fraction. Type the negative, type the 1/2, and it automatically gives you the 1/2. Now, what's really important, though, is right now, if I just type x, it puts x in the bottom, and we see a pretty goofy looking shape here. And that's not what we want. So what we need to do is move to the right of that fraction and then type x. Now, it was negative 1/2 x plus 3. Okay, and we look at those two graphs, or we look at those two lines, and we look for the point where those two intersect, and we come right up here, and we see that they intersect at the point negative 2, 4. Okay, so we'll get a copy of this picture, so we'll share, export the image, okay, and we will right-click, copy image, come back here, right-click, paste. All right, and we're going to have to make this a little bit smaller, but that's okay. And try to keep it consistent. You stretched it vertically a little bit, it's okay, we'll square that up. And there we go. Okay, so the point of intersection, okay, where these two lines intersect, is the ordered pair negative 2, 4. Okay, that's the ordered pair, that's our solution. So that's what we write. Okay, now I also want to show you another platform you can use. If you have a regular old graphing calculator, or if you have the Wabbit Emu app on your calculator, or the Calculator X, really any graphing calculator app on your phone, what we can do is use that to graph these systems as well. Okay, so let me make that smaller so I can see everything. There we go. I want to solve this system here. Okay, so I have y equals x minus 2 and y equals negative 2x plus 7. Well, good news for us here. Okay, these both already have y by itself. So on most calculators near the top, you're going to have a button that says y equals. And if you go in there, you can type in y equals, okay, this button right here with the x, the t, and the theta, and the n, that gives you your x minus 2. Okay, hit enter. And then your second equation, type negative 2x plus 7. Okay, now it has both of these functions, and it'll put them both on the same graph. So there's another button up here that says graph. Okay, and you can see it'll graph both of those functions. Now we do run into a small problem here because we don't have that nice, neat grid that we had on Desmos to find that solution for us. But these calculators do have a program in them that will solve the system for us. So if we go to, let's see, up here above trace, you see in blue it says calc. Okay, so we'll do second calc, and that will calculate certain values for us. And if we notice down here, number 5 says intersect, and we can find the intersection of those two lines. So scroll down to intersect, or simply press 5. Okay, now down here you can see that says first curve, and it's blinking, the cursor is blinking right here on the point 0, negative 2. And that's on our y1, first equation that we typed in, y equals x minus 2. Okay, we press enter, and then it asks for the second curve. And now the cursor is blinking up here. Okay, and that's the second line that we graphed, y equals negative 2x plus 7. Okay, so we press enter. Now it's asking us to guess. So it's got a cursor, it's got a crosshairs right here on the first function. It's got a crosshairs right here on the second function. And now it's asking us to guess about where we think that intersection is. The reason we have to do this is because if it's not a straight line, sometimes we'll graph curves. There might be multiple places where they intersect. So we need to get that cursor using the right and left arrow keys close to that intersection. Now we don't have to worry about landing directly on it. As long as we're close by, okay, it'll get the job done. So you can see this cursor is blinking right around where those lines intersect. We press enter, and it tells us the intersection is the ordered pair 3, 1. So we want to get a picture of this. Okay, well, there's a couple different options we can do. If you're on your phone, you can do a screenshot. If you're on the computer, you can also do a screenshot, but then you'll have everything on the screen. Okay, so you might want to take that into some sort of photo editor and limit down to just this window. In fact, let's see. Variables, calculator, paste the value, speed, options, file, record, take screenshot right here. Here we go. Okay, and pick somewhere to save it. Okay, so I'm going to save mine right here on the desktop. I'll call it Systems Example 3. Okay, I'll save it. All right, then for me, I want to insert media, desktop, and where'd it go? Systems, there we go. Okay, and there we go. Okay, and that's our graph, that's all of our work, and we can say that our solution is the ordered pair 3, 1. Okay, and here we go. Okay, so let's take a look at a couple more. Tell you what, I'm going to skip this one right now because it's the same one that we did a minute ago, and I'll look down here. Okay, now this equation, we already have one of the y's by itself. On this one, we need to get y by itself. So we'll start by adding subtracting 3x from both sides. Okay, and that will give us negative 2y equals negative 3x plus 4. Okay, Now, we got to get y all the way by itself. So next up, we'll divide both sides by -2, okay? And that will give us y all by itself, and y equals -3 divided by -2 is a positive 3 halves x. Positive 4 divided by -2 is going to be -2, okay? So we have our two equations, and we want to graph them both. So we'll take this guy and this guy. We'll go to our graphing calculator, okay, go into y equals, clear out both of the equations that were there, okay? And for y1, we'll type in negative, or the opposite of, x plus 3. And for the second equation, we'll type in 3 halves. Now, on the graphing calculator, to type in 3 halves, just put in parentheses 3 divided by 2, okay? And we can even see that kind of looks like a fraction. So 3 halves times x minus 2. Okay, press enter again. Go to the graph. And there we see it graphs both of those lines. Now, we want to find the intersection. So we go to second, and then up here in blue on that trace button, it says calc. We're going to calculate the intersection. Okay, so we can just press 5, and it'll take us right to that finding the intersection. And it's blinking on that first curve, y equals the opposite of x plus 3. And it's blinking right here. Press enter. Second curve, okay, it's blinking right here. Press enter. Now, we need to guess. So we need to use the left and right arrow keys to get close to that intersection. Now, we don't have to be directly on it. We just need to be close to it. Okay, press enter. And it tells us that the solution is where x equals 2 and y equals 1. So I'm going to take that screenshot. Okay, call it Systems Example 5. Okay, and then I'm going to insert media, go to the desktop, Systems Example 5. Whoop. And I'll move that right over here. Okay, and then I can say that the solution to this system is the ordered pair 2, 1. Oop. There we go. Okay, there's my answer. And there we go. Now, let's take a look at just a couple more and see what else can happen. Okay, let's look at a couple of those special cases. So we'll go down here, number 7. Okay, on number 7, I have 3x plus y equals 5. Okay, well, I definitely need to get that y all by itself. So the first thing that I'm going to do to get that y by itself is subtract 3x from both sides. Okay, and that will give us the equation y equals -3x plus 5. Okay, now this second equation, we're going to have to do just a little bit more. So we'll start by subtracting 15x from both sides. Okay, and that will give us the equation 5y equals -15x plus 2. Okay, okay, now we're going to go ahead and divide both sides by 5. Okay, and we have right here, and then divide this side by 5. Okay, and just remember to divide everything by 5. So the left side's easy. 5's cancel. Got y all by itself. And on the right side, -15x divided by 5 is -3x. Okay, and then 2 divided by 5, well, that's 2/5 or 0.4. Okay, and here is the same system of equations. So we're going to use these, and we're going to type them in here into the graph. So go into y equals, clear them out. Okay, and we'll type in -3x plus 5, enter, -3x plus 0.4. Hit enter, go to the graph. Okay, and I don't see anywhere where those two lines intersect. Okay, so what I'm going to do, just to be clear, okay, we'll go into the graph, we'll go into calculate, we'll calculate where those two lines intersect. Okay, first curve, second curve, take a guess. Well, it doesn't really matter where I slide along here. What we'll see is that there is no sign change. Okay, so what that means is these two lines don't intersect. They're parallel. Okay, so we can just say right here, actually, well, I guess I'm going to do a little shortcut here for us. And then come here and paste. No? Take a screenshot. Call it systems example 7. Save. Insert. Media. And there we go. Okay, and we can see that those lines do not intersect, therefore there is no solution. Okay, so we can write the words no solution, or we can use our old friend C, say there's no solution to this system. Okay, lastly, one more example, so we'll get rid of this guy for now. It takes a little bit longer to get your pictures on here, for me at least. Okay, we'll come down here. Okay, so last one. This one already has y by itself, so this equation I need to get y by itself. So I'll add 4x to both sides. Okay, and that will give me 2y equals 4x plus 6. Okay, then I want to divide both sides by 2. Okay, and that will give me y equals 2x plus 3. Well, take a look at these two equations, guys. They're the exact same equation both times. Okay, this is a system of equations where the same equation is written two different ways. Okay, now that can absolutely happen. Once we recognize that these two equations are exactly the same, we realize that this is one of those special cases that we talked about back at the beginning. If both equations graph the same line, then the system has no unique solution. Now, once we recognize that they're the exact same equation, we don't actually need to graph. Okay, we can just go ahead and say no unique solution. Now, before we go ahead and say that, though, we do want to make 100% certain that these two are the same equation. So we can't just go right out of the gate and say there's no unique solution. What we need to do is get y by itself in both equations. If it's the exact same equation both times, that's no unique solution. So, if we want to solve a system of equations by graphing, first thing that we need to do is get y by itself in each equation. Graph each function very carefully, best to use a graphing calculator, and find the point of intersection for those two lines. If where those lines intersect, that's your solution. If those lines do not intersect, then they're parallel, and there is no solution. If both equations graph the exact same line, then the system has no unique solution, and then that is our answer.